Looks good.
Looks good?
Yeah.
All right, so the reflex arc is, like I put, the simplest neural pathway in the body. So there's three main types of neurons that exist. There are sensory neurons, there are interneurons, and there are motor neurons. So obviously we've drawn out a better neuron to show all those parts and functions. But like, for example, these are missing, dendrites. They may be myelinated, right? They might have, Schwann cells that are secreting myelin, etc., etc. So we're just drawing some simplified forms. The interneuron and the motor neuron look very much the same. The main difference between the two is location, location, location.
Okay.
So the interneurons are going to be found in the central nervous system, so in your spinal cord and in your brain. So if they're internal, like inside that central nervous system, then they're interneurons. Motor neurons can be found, even though they look the same, they're often the ones that are coming out of the central nervous system to the peripheral nervous system.
Okay.
And then the sensory neurons look a lot different. They kind of like an octopus. They have a little bit of axon ahead of the cell body and a little bit of axon after the cell body. And they have a very specialized dendrite.
Okay.
So each sensory neuron will have a dendrite that is designed to detect one type of specific stimulus. For example, the dendrites in the sensory neurons of the eye, like the rods and the cones, they will have a dendrite that's designed to detect light energy. So if you blast sound waves at a sensory neuron, it doesn't do anything. It just sits there. It's like, I don't know, right? But if you shine a light on it, then it can cause an action potential in the sensory neuron.
Okay.
Same thing with the little hair cells in the ear. If you blast them with light, they don't do anything. As soon as you get some motion in them, like due to sound waves, that mechanical energy will be converted to an action potential, which sends a message.
Okay.
Fair enough?
Yeah.
So that's really important, that sensory neurons can detect one type of stimulus. So in your finger, which is represented by this beautiful diagram, right? At the tip of your finger, can you detect pressure?
Mm-hmm.
Can you detect position due to gravity?
Yeah.
Kinda. Can you detect temperature changes?
Mm-hmm.
Can you detect light? No. So there's probably 3 different types at least of neurons that go to your fingertips that are going to detect the gain or loss of temperature, of energy, heat energy. So if it feels cold, it's because heat is going from your finger to the board. If it feels hot, it's because it's coming the other way. There will be ones that can detect pressure. There will be ones that can detect, in some areas of your body, it's called proprioception, so where you are in space.
Okay.
It can detect pain as well. So when the pressure is too great or something is cut, whatever, it'll send a message that the brain then goes, hey, that's this kind of neuron firing, so it must be painful.
So is it all like different ones, or is it all like the same one?
All different ones.
Okay.
Yeah, all different ones. That's a very good question. So that means in my fingertips and in the tip of my nose, because if you do this and you go close your eyes and you say, do I feel my finger or do you feel my nose? Most people will say, I actually feel my nose.
Okay.
So there's probably a higher accumulation or a higher concentration of neurons in your tip of your nose and in your fingertips than there are, say, in your elbow.
Yeah. Okay.
Right? Because you can squeeze on that and you really don't feel anything.
Yeah.
So that's one of the reasons, is the concentration. The other reason might be the threshold level of those neurons. The lower the threshold, the easier it is to get them to send a message.
Okay.
The higher the threshold, the harder it is. So the simplest neural pathway consists of one of each type of those neurons. A sensory neuron, an interneuron, and a motor neuron. And it's actually designed to bypass the brain, because usually information is coming from the outside world and the inside world, and it's going to our brain, and the brain is where all the interpretation occurs. It's the computer that's going, oh, this is what that means,
Right. Yeah.
right? But in the case of a reflex, we don't want the message to go to the brain and then have to travel back to where we need some kind of an action. Because it takes longer to get from the fingertip to the spinal cord, up the spinal cord, to the brain, process through a bunch of neurons in the brain, then come back down the spinal cord and then go here. This is a quicker trip,
Okay.
right?
Yeah.
And the reason we want a quicker trip is to get us out of trouble as fast as we can.
Right.
Okay? So if a ball or something is flying towards your eyes, naturally you blink.
Mhm.
You don't think about it, you just blink. It's called a blink reflex. If you put your finger on a hot stove, or for some reason over top of a candle, right? Then we need to get that out of there as quick as possible to do the least amount of damage to the cells in that area. So the reflex arc's job is to do that, okay? Does the message still get to the brain? Yes, it does. It's still gonna get information from your sensory neuron to your spinal cord, and then it's gonna go up to the brain, and then it's gonna go around probably some kind of a brain pathway, and eventually it's going to get back down to here, right? But the trip is longer. How do I know it gets to the brain? Because generally what I do when I put my finger on something hot is it moves without me
Right.
thinking about it,
Yeah.
and then I say, ow.
Oh, so like it kind of happens after.
It happens after. And it's not much after,
No.
but it's enough of a time over top of something hot that it saves cells in that area.
Oh, okay.
Okay, and so these little reflex arcs, they call them, because it's like, you know, the golden arches. If you had another one, you'd be at McDonald's, right? So it's an arc that's created to get you a really, really quick response, and those occur all over your body. You have reflexes like if you go to the doctor and they hit you on the kneecap, right? Your leg pops up, and that's just to relieve the pressure that he's putting on that tendon and ligament in the knee when he hits it, or she hits it, right? So the parts are as follows. Number one is a specialized dendrite that's designed to detect one type of stimulus. So in this case, it's probably a temperature.
Right. Yeah.
A change in heat energy is going to be detected by that special sensory receptor. Now that's not a part on its own, that's just a specialized part of the sensory neuron.
Okay.
Okay, it's like these guys have dendrites, these guys also have dendrites, they're just specialized.
Okay.
Okay, and then we have number two, which is the sensory neuron. Its job is to, once threshold is overcome and is detected by its own little fancy dendrite, it sends a message to the central nervous system.
Okay.
The interneuron, which is number three, just forms the arc. So it bypasses the information traveling to the brain. Now, that would also be an interneuron that's going up to the brain.
Okay.
But this interneuron in particular makes the little arc and really quickly gets the message right back out to where it's going to get it out of harm.
Okay.
Okay, and then we have number four, which is the motor neuron, the little green guy. The motor neuron is taking the information quickly from the central nervous system to the periphery, to your peripheral vision, to the periphery of your body, the outside. So it's going to the peripheral. This is part of the peripheral nervous system. So it's taking the message back out to an effector, which in this case is number five, is a muscle. So an effector is it's going to cause an effect somewhere in your body. So it's usually a muscle, so we're getting motion. Could be an organ, could be a gland that we want to activate with a neuron so that it does something. In this case, our effector happens to be a muscle cell.
Right. Yeah.
And that muscle, all it does is shorten, which if I shorten this muscle, my arm comes up. Okay, so 5 parts to the reflex arc. And if you look here, we've got them listed. Special sensory receptor, sensory neuron, interneuron, motor neuron, and effector. And it's always those parts.
Okay.
And the reflex always occurs in that order.
Okay.
Okay? So it's always going from the stimulus to the effector, which is giving us a response.
Okay.
Right? Okay? And so, that message comes in, makes an arc, goes back out, causes it to do something.
Right.
Right? So I just give you some kind of general definitions of those, like a special sensory receptor is a dendrite specifically designed to detect one type of stimulus. Okay? Again, every type of stimulus that you want to detect is going to need a different type of neuron.
Right.
Right? Sensory neuron is any neuron that's going to carry that information or impulse to the spinal cord, to the central nervous system. In this case, we're talking about to the spinal cord. Interneuron, it's going to bypass the brain by making a quick arc back to the motor neuron. Now, not all interneurons do that, just the one in the reflex arc. And then the effector is, motor neuron is the neuron that's going to carry that impulse back out to the effector, and the effector is, in this case, a muscle, which it causes it to have an effect. So the muscle contracts. And that's the reflex arc.
Okay.
Right? So, a typical kind of application question on the diploma exam will show a diagram similar to this. Sometimes they show the spinal cord kind of like this. But so here's spinal cord, and here's like kind of a middle of the spinal cord, and these are branches coming out of the spinal cord, right? And so if this was a cucumber, and you sliced your cucumber to make rings, this is a ring.
Okay.
So it's like a ring of spinal cord.
Okay.
Okay, so like a spinal cord dissection. So we've got sensory neuron coming in to here. We've got interneuron making an arc. We've got motor neuron coming back out. In and out is usually the type of picture that they draw.
Okay.
So if you just got that and you're like, I don't even know what that thing is, right? Hopefully this helps you with that.
Yeah.
So again, they might have a picture like this. It might be someone's ankle, it might be someone's knee, it might be a hand.
Okay.
But you're going to get where you have a stimulus. They'll usually have an arrow pointing at the stimulus somewhere. A direction of impulse. Sometimes they put that in there. Sometimes they want to know if you know the direction.
Okay.
Right? Since we always know that it goes in that order.
Yeah.
Right? And sometimes the question is, say it was a knee, and a doctor taps the knee, and the person's reflex, nothing occurs. The leg just stays there. But the person says, I can feel the hammer. Okay? So where could there be damage in that case?
The motor neuron?
It could be so absolutely. So the fact that I can still feel it means this is intact, right? The fact that nothing happens could be damage to the muscle, could be damage to the motor neuron, could even be damage to the interneuron that's making the arc.
Okay.
And so if they label those with numbers, then you would just pick the numbers that could be damaged. You wouldn't pick 1, you wouldn't pick 2.
Right, yeah.
Right? You could pick 3, 4, or 5 in that case.
Okay.
So that's taking your knowledge now of simple parts and functions and applying it to a scenario.
Okay.
Right?
Yeah.
And so questions that you might see can be at that level. Do you know the parts and functions of the reflex arc? Or they could be at this level. Now that you know them, apply this.
Oh, okay.
Like, how come they feel it, but they get no reflex? Right? Where could there be damage? So that's, well, it could be here and here. I know that because that's sensory, that's inter, that's motor. I know it goes in this direction, so that's all the basic knowledge.
Okay.
And now I understand it because I'm applying it.
So will they specify if like the person felt it or
Yes.
not? Okay.
Yeah, that would be in the question.
Okay.
Absolutely.
That makes a lot more sense.
All right.